Welcome, students, to this explainer. Today, we are going to completely change the way you look at the world around you. We're going to reframe math entirely. Forget the old idea that mathematics is just some rigid set of rules you have to memorize for a test. Instead, I want you to start thinking of it as an artistic, deeply creative language of hidden patterns. It is, quite literally, the invisible architecture of everything we know. So, let's kick off this discovery session with a bit of a mystery, all right? How in the world does drawing a few simple dots on a piece of paper actually connect to engineering the massive suspension bridges we drive across every single day? How do we go from a pencil tapping on a page to the complex code running the mobile phone right there in your pocket? Keep that little puzzle in the back of your mind, because by the time we're done here, the answer is going to seem beautifully, perfectly obvious to you. Let's dive in.
Section 1. The Magic of Number Sequences.
To crack this case, we really need to lay down a solid foundation. We have to understand that mathematics is fundamentally about hunting down patterns, and more importantly, figuring out the explanations for why those patterns exist in the first place. We aren't just asking what happens, we are relentlessly asking why. Now, on our virtual chalkboard today, we've got the core sequences of whole numbers that'll be our main tools. You already know your counting numbers, your odds, and your evens, but we're also going to get hands-on with triangular numbers like 1, 3, and 6, and square numbers like 1, 4, and 9. These are not just random lists of digits, they are the literal building blocks of structure.
And finding these patterns? It is a deeply creative endeavor. It takes real imagination to look at a chaotic universe and find the underlying rhythm. That is exactly why mathematicians actually consider their field to be just as much of an art form as it is a science. You are not just human calculators, you're artists learning to see the canvas of reality.
Moving to Section 2, Visualizing Squares and Triangles. Okay, so just like an artist needs to actually see their subject, we need to take these abstract numbers and translate them into physical shapes we can draw. Numbers don't just live in our heads, they take up physical space. When you map them out, you can see how numbers like 1, 4, 9, and 16 perfectly form geometric square grids. And those triangular numbers start with 1, add a base of 2 to get 3, then a base of 3 to get 6. They stack up beautifully, layer by layer, to build perfect triangles. We are turning pure concepts into physical blueprints.
The really crucial takeaway here is that numbers have structure. Take a magical number like 36, for instance. If you have 36 dots, you can arrange them to stack into a perfect triangle. Absolutely. But you can also arrange those exact same 36 dots into a perfect 6x6 square. It brilliantly illustrates how the exact same number can play entirely different structural roles depending on its context. It's like a geometric chameleon.
Which brings us to Section 3, the secret of odd sums. Now that we can visualize these shapes, let's figure out a new mystery together. Let's act like true mathematical artists. What happens if we just start adding up odd numbers, step by step? 1 is just 1, but add the next odd number, 3, and you get 4. Add the next one, 5, and you get 9. Do you see what's happening here? Add 7, and you get 16. Every single time we sequentially add the next odd number, we get this amazing aha moment. The sums magically transform into perfect square numbers, 1, 4, 9, 16. But remember our rule, it's not enough to know what happens. Does this pattern go on forever, and why?
Well, a picture can explain it perfectly. Imagine you are drawing this out yourself right now. You start with a single dot. Then you take your next 3 dots and you wrap them around that first dot like an L shape. Boom! You have a 2x2 square. Then you take the next odd number, 5 dots, and wrap them around the outside again, creating a 3x3 square. Every time you introduce the next odd number of dots, it acts like a fresh new layer wrapping flawlessly around the previous grid to build a larger square. Honestly, this is one of my absolute favorite concepts. This beautiful artistic illustration isn't just some neat visual trick, it is a rock-solid mathematical proof. Because you can always add another layer of odd-numbered dots to a square to build the next size up, we know with absolute certainty that this geometric relationship goes on forever. We literally proved it just by drawing it. And the patterns definitely don't stop there. We can uncover so many more secrets. Think about what happens if you add counting numbers up and then right back down again. 1 plus 2 plus 1 is 4. 1 plus 2 plus 3 plus 2 plus 1 is 9. It gives us yet another completely different, perfectly valid way to generate perfect square numbers. Mathematical art just gives us all these different tools to build the exact same structures. Let's zoom out for Section 4, Patterns Propelling Human Progress. Okay, so you're learning to spot patterns in dots on a screen. But how does this translate to the real world? Let's circle back to our initial mystery. How do these foundational rules of dots and grids apply to the massive technological world we actually live in? Here is the incredible truth. The exact same creative problem-solving you just used to find patterns in those abstract sequences, wrapping layers of odd numbers to build squares, is the fundamental logic that engineers use to build the modern world. Whether you are analyzing a physical bridge to ensure it distributes weight safely across its geometric trusses, or you're writing the complex algorithms that run the apps on your mobile phone, you are applying the science of patterns.
History proves this time and time again. By recognizing visual patterns in the motion of the stars, humankind developed the theory of gravitation, which literally allowed us to launch rockets to the moon and to Mars. By decoding the insanely complex number patterns hidden inside our own genomes, we are learning how to cure diseases. Spotting these mathematical patterns isn't just a fun exercise, it is literally the engine of human progress.
Think about geometric shapes, like regular polygons or stacked triangles. These aren't just boring shapes in a textbook. These are the structural blueprints required to construct our everyday lives. A suspension bridge absolutely relies on the mathematical properties of stacked triangles to maintain tension and stay standing against the wind. The digital displays on our TVs and phones? They are built on microscopic grids governed entirely by square number sequences. The art of math is literally everywhere you look.
So, my students, as we wrap up our discovery session today, I leave you with a challenge. When you walk out into the world today, I want you to look at your surroundings just a little bit differently. Don't just see a building, look for the stacked geometry holding it up. Don't just glance at a flower, try to spot the number sequences unfolding in its petals. Where will you spot the next artistic, mathematical secret waiting to be discovered? Because those patterns are out there, hiding in plain sight, just waiting for a creative mind to find them. Keep exploring, stay curious, and I'll catch you in the next explainer.